Hey guys, in this tutorial I want to take a look at cumulative relative frequency graphs, and you have a problem on one of your assignments that asks you to calculate the percentile of the median household income for the state of California. So my x-axis is the median household income. I'm being told what the median income is. Highlight that for you. I'm being told the number, so it's asking me. You have to be very careful to recognize what it's asking us for. So since it's asking us for a percentile, these are always our percents in a cumulative relative frequency graph. So I'm going to figure out where $57,449 is, and that's about right there. So you're simply going to start a vertical line and you're going to go all the way up until you touch the graph. And your line doesn't have to be perfect, but you do have to show your work. I'm going to erase this circle, and then after you hit the graph, you stop and you turn 90 degrees. So we're going to now travel to our horizontal axis. And at that point, that's about the percentile. So it looks like it's a little bit above 70%. So that looks like maybe the 70th percentile, 71st percentile, somewhere around there. So I'm just going to write the 70th percentile. So we've answered our question, we've shown our work. For part B, it says estimate and interpret the first quartile of this solution. So you have to know what quartile means. So again, they're giving us first quartile, but they're asking us to estimate and interpret what that number is. So let's go back to our graph. First quartile is always 25%, so I'm going to switch my color. 25% is right here. I'm going to travel horizontally till I hit the graph, and then I'm going to take a 90-degree turn, and I'm going to go down. And it looks like 45 is my number, but you have to use context here. I think these numbers are in the thousands based on the wording of part A. So the answer is for the first quartile $45,000 approximately. So that's our estimate. You definitely don't want to say $45 because a house is not only going to cost us $45. So we're going to write 45,000 is our estimate. But it also asks us to interpret what that means. And what that means is in the state of, I guess, is this California still? It means that about 25% of the homes are going to cost less than, or not cost less, the income level is going to be less than $45,000. Sorry, I got mixed up there. So the interpretation is 25% of the household incomes will be less than $45,000. So we want to make sure we write that. So with the power of recording, I wrote that out. Let me just zoom in and make sure I worded that correctly, because this is income data. I don't have any other context here. Median household income. Estimate and interpret the first quartile of this solution. So that means first quartile is 25%. We'll have a median income of less than $45,000. So it would probably look a little bit better if I added median before the word income, but we have enough context there to get us credit, and the understanding that percentile is measured below. Let's take a look at number 4 on this page. We're told that teachers' salaries are between $40,000 and $71,000. They're negotiating an increase. That's nice. So if every teacher is given a $1,000 raise, what is this going to do to the mean salary? So measures of center, if every single item in your data set increases or decreases by a constant number, your measures of center will also increase or decrease accordingly. So we did an activity in an earlier lesson. If you need to revisit that activity, please do so. But if you mathematically mapped it out, if every single person gets a $1,000 raise, then the mean salary and the median salary will both increase by $1,000. The distribution is literally going to shift to the right by 1,000. I'm not going to write that out, but hopefully you understand that and can write that down on your assignment. Let's take a look at B. What would a flat $1,000 raise do to the extremes and the quartiles of the salary distribution? So the big idea here is your extremes are your max and mins. So, sorry about that, Belle. Your maxes and mins, your extremes, are going to shift just like they did in part A. So your extremes will increase by 1,000. But what you have to understand is there's no variation. If everything is moving, the variability is staying the same as it always did. So measures of spread are never affected when you increase or decrease every single value by a constant number. So let me be clear here. What would a flat $1,000 raise do to the extremes? Well, they're going to increase by $1,000. But the quartiles are also measurements, like individual measurements. Those quartiles will also increase by $1,000. The standard deviation, though, is a measurement of spread. So standard deviation, or IQR, is not going to change. So individual points will change, but measures of spread will not. So please make sure you understand that part. For now, that wraps it up for our lesson on cumulative relative frequency graphs and specific measurements within a distribution, how they're affected by adding or subtracting a constant number. I hope this helps you guys some. Have a great day.